Yesterday you guys watched a video about naming alkanes, right? Some of you did very well, I heard, and others were having some issues figuring out a few things. So let's just talk about naming in general. What were the rules that she came up with or helped you guys figuring out? So naming alkanes. So the first step is really to locate the parent chain, right? The first step is locate parent chain. Now, when you're looking for the parent chain, does it have to go in a straight line? No. You're looking for the longest string of carbons that you can make, okay? And trust me, even I, looking at it, sometimes think this is the parent chain, and I do have to question, and then I get frustrated because I realize this one has one more in this path, and I have to go back over it, okay? They're big, long molecules to look at. In the video, she talked about all the way to 20. We're only going to 10, okay? And if you notice on your, is it pink piece of paper that has all the prefixes? It has the regular prefixes, and then it has organic prefixes. Your organic prefixes are there till 10 in that pink page, right? So you're going to need this. You're going to want this pink page out right away, okay? So if you don't have it, carry it with you. We need it. If you noticed, the first one is METH. It is not meth. It's meth, okay? Methane, methane. It can be said a couple different ways, okay? Eth, prop, bute, pent, hex, hept, oct, non, dec, okay? Some of them are the exact same as the regular prefixes, but usually I think it's the first four that are a little bit different, okay? Now, once we locate the parent chain, that tells us what is our prefix. If our parent chain is saturated, that means it has all single bonds, right? Did you guys learn that term, saturated, has all single bonds? That means it's an ane, okay? And that's all we know how to name right now. So everything is going to end in ane, alkane, okay? So it'll be butane, pentane, decane, stuff like that. Thanks. Once we locate the parent chain, what was your next step? Was to number them. Now it's important that you can number them in different ways. What was really important about the ways of numbering? You had to number starting at 1 so that you meet a branch right away. If you number 1 to 10 one way and you number 1 to 10 the other way, and the branch meets at 2 on this side and at 6 on this side, you're going to start with the one that starts with the 2. So it'll go 1, 2, 3, 4. Okay? So just make sure that you're numbering the parent chain so that you hit branches early. Branches sooner than later. Okay, so once we've got them numbered, what did you guys notice your next step was? Wasn't it to look at the different types of branches you have? Okay. Name substituents. So find the branches, okay? Fancy word, substituents. You're looking for the branches that are on there, okay? So I don't even know if I can spell substituents today. Did I do a good job? No. Okay, so what were we supposed to do with these? Just locate them? Is step 4 locate them? What's step 4? Can I put that all in one? name, locate, order them, okay? So even if you have a methyl group, and if they're substituents, they don't end in ane, they end in a YL, okay? So your substituents end in a YL. We name them, locate them, and we put them in order. So if you have a methyl, even though that's CH3, and you have an ethane, eth is 2, right, which is a CH2, CH3. Ethane comes in the alphabet, E comes before M. So we name that one first, and then we name the methane, or the methyl group, or the methyl group second. Okay? So, other than that, I don't think there was much more to that naming. Is there any more steps that she made you write down? Oh, name, locate. The numbers would be the locations, right? And I guess we should make a note to use hyphens for what? To separate between the numbers and the substituents. Is that what we do? Commas are between numbers, dashes are between numbers and words. Okay. Whew, you guys learned lots. Now, in your textbook, sorry, I should flip the page next. In your textbook, there's these common groups. Now, you guys have seen methyl and ethyl and propyl. I don't know if you saw an isopropyl. Okay? Isopropyl is just a different kind of thing of propyl. Propyl, the C at the end has the attachment point. Isopropyl, the C in the middle has the attachment point. Okay? And then butyl is just a regular 4 one. But I just wanted to show you that there are other ones. There are also alcohols and different things that get attached, but they're there. Okay? So, just want to start on a couple examples, just so that we can see them. I just exited my... Okay. So I just want you guys to see this. Can you see this? This is the group you're at. Have you done a lot of these? Okay. Some of you have done more than others. Okay. I apologize. Some of you caught on fast. That's great. I apologize. You might have to sit through 1 or 2 of these together. Okay. So I'm going to go down and I'm going to look at this one right here. Okay? So if I look right here, if I count straight across, I've got 1, 2, 3, 4, 5, 6, 7. If I count from here and around, I get 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the parent chain is the one with the longest chain. So in this case, my parent chain is right along the top. That's my parent chain. How many did I count across there? 7. So I'm just going to make a note that I have 7 carbons down there. I apologize for it not being too close. Maybe I can bring it closer for you guys. But we have 7 carbon. Now, which way do I have to count so that that substituent appears closer to the end? So if I count this way, I get 1, 2, 3, 4. So on the 4th, if I count this way, 1, 2, 3, 4. Well, it really doesn't matter which way I count because 4 and 4, they're the same exact number. So I'm just going to put numbers across 1, 2, 3, 4, 5, 6, 7. Okay? So I've got it numbered. I need to figure out what is this substituent. CH2, CH3, that's a 2 thing, right? 2 carbons. If I look here, 2 carbons is eth, right? So that's ethyl, right? So I could just make a note that this is ethyl if I wanted to. It helps if I have lots of them to make notes, but as you get better at naming, you won't have to make so many notes for yourself, okay? It's on the 4th carbon, right? So to go about and name this, I'm going to write, well, my substituent is on the 4th carbon of my parent chain. I'm going to dash it, and I'm going to call it that substituent, ethyl. There's 7 things in the parent chain, so that means 7. I look up by prefix. In the organic, that's hept. Okay, so then I call it heptane. And that's my name. Okay?
Is there supposed to be a dash in
I don't believe so.
where there's the pictures, they have dashes.
Oh.
And I think the annotated, do you just add a then?
We can put a dash in. We add the end of ane because it's a substrate. It's a saturated carbon. So anything that has single bond carbons all the way across. So they're saying I should have a dash. And in all my answer keys I don't have dashes, but if you look at the next page where it gives you the name of something, so you can put a dash there. You can not put a dash there. I'll be okay for this class. But when you get into organic chem, you basically should figure out, does that dash belong there? And I'll take a double look here tonight and make sure that I know. Yes?
So if you don't put a dash, do they have to be like right together, or can there be like a little space?
There should be a little space in between them because they're different words. And I think that's why the dash belongs there.
Okay.
Now, I just want to look at a little bit more complicated one. So I'm going to go down to about here. So that's 2 below, 3 below the last one that we talked about. Okay? So even in this case, locating the parent chain, if I count across, I get 1, 2, 3, 4, 5, 6, 7. And if I count here, I go 1, 2, 3, 4, 5, 6. I'm never going to get anything more than 7, right? So this one is a 7-carbon parent chain as well. Now, this one, it might matter which way we count. So if I count this way, 1, 2, 3, 4, 5, 6, 7. Or I go 1, 2, 3, 4, 5, 6, 7. They both start with 3s, right? They both hit with 3, so it really doesn't matter either way. They're still at the lowest thing. If I have a choice, lots of times, I'll write left to right just because that's the way I've been trained in English and stuff like that, is to read left to right. So I'll write left to right. Some people might say because there's 2 substituents this way on the 3, this is the better way to go. Okay? Now, what kind of substituents do we have? CH3, CH3, CH3. They're all the same substituent. What are they? They're all 3 are methyl. Because there's 1 carbon on that chain. And 1 carbon, if we go to our organic prefixes, means meth or meth, right? And if it's a substituent, we end in YL. Okay? Is this okay so far? So then we name it. So we have to locate those things. If we call this 1, 2, 3, so this is 3 and 3 and 5, right? So we're going to write 3, 3, 5. Now, here's the other thing. We use normal prefixes to name how many substituents we have. And we should have included that in our instructions. So how many substituents do we have that are meth? 3. So we call it trimethyl. So dash, trimethyl, dash. Now it's a 7-carbon chain. So 7 carbons.
You have to write that dash. You have to.
7 carbons is hept. So we'll call it heptane. I never did in my answer key, but they're saying because if we look at the questions here, like these ones, there's dashes in those ones. They think I just made a mistake in my answer key. I'm going to double check. If you listened like 2 minutes prior, I said I'm going to double check tonight. And I'll answer you tomorrow. Yeah.
If you had a chain that had like a CH2, CH2, and CH3, would you have to label that there was two CH2s?
If you had a chain that said CH2, CH2, CH3, like as a substituent chain, that is 3. So if we look at 3, that's a propyl group. Okay, so you wouldn't name it as a 2, a 2, and a 3. You'd name it as there's 3 carbons. That's a propyl group. Okay, so do you want me to do the one right below, right here? Okay. Okay, so let's write this next one, and then we'll do the very bottom one on this page. Okay, so if I look, the longest parent chain on this one is 1, 2, 3, 4, all the way across again, right? So there's 4 carbon chain. Which way do we count for the substituents? We count backwards because we're going to hit 2 if we count backwards. 1, 2, 3, 4. Whereas if we counted forwards, we'd hit 3 and that would be further past, right? So we have to count backwards so we hit the substituents early, right? What are our 2 substituents? They're both methyl, right? Or methyl. Now, we have to write where they belong, right? And they're both on the 2. So we write 2, 2 dash, what's the prefix for 2? Dimethyl dash, now it's 4, so the organic prefix for 4 is bute. So now this is butane. And why do we end in ane, you guys? Because it's an alkane. How come it's an alkane? They're all single bonds on the parent chain, okay? If there were more than single bonds, you end up with an ene or an ine, and we're going to talk about that when we come Thursday, Friday in chemistry, okay?
So would you be able to just write 2 dimethyl butanes instead of 2?
As far as,
They're both there.
I don't know. That's another thing I can check. I don't believe so. I think you have to put the 2, 2, but I could be wrong. And one's going down. But the dye, I get where you're going with the dye. Okay. Carrying on, the last one. How do we count the longest chain? This one tricks people all the time because people want to go just forward. So they would count 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 4, 5, 6. They only go forward. So they would say that their parent chain is sitting right here on the top when we count it here. But, you guys, you can count backwards. Remember that it's okay. We can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you see that parent chain in there? Your parent chain is right there. It's 10 carbons. Okay? That mistake is made more than enough. Why? Because we're trained to read just forward. We just go left to right. That's all we do. But in chemistry, we can read around. Okay? So our parent chain has 10 carbons. Which way do we count so that the substituents end up early? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 1, 2, 3, 4, 5, 6. The bottom one, we have to start with this bottom one, so we count this 1, 2, 3, 4, 5. Do I really need to count the rest? No, because there's no other substituents is there. Yes?
How do you know which ones are the substituents in this
they're the ones that come off of the parent chain. So, for example, if we look here, our substituents are the ones that come off of the ones that I have drawn that circle around the parent chain. So those are my two substituents. Up in the ones before, we drew a circle around my substituents. So like those come off the parent chain. So anytime they come off of a parent chain, those are our substituents. We don't ever include part of our parent chain as a substituent. Okay? So we have different substituents this time. We have one that's just one carbon, and we have one that is two carbons, right? So this CH3, the one carbon, is a methyl group. This other one, CH2CH3, that's a two carbon. Two carbon is eth, so that's an ethyl group. But they're both on the fifth carbon, right? But in order to name this, we have to name in alphabetical order. What comes first, E or M? E. So E, ethyl, is on the 5, so we're going to write 5-ethyl, and then dash. We're going to write the methyl group. It's still on the fifth carbon, so we're going to write 5-methyl, and then it's a 10 carbon, right? Which is a decane. So dash decane. Okay? Good? Yeah.
Does it matter which one goes first?
It does matter which one goes first. You write in the order of the alphabet. So if someone wrote 5-methyl, 5-ethyl, they'd have it incorrect, because we always write in the order of alphabetical for the substituents.
So it doesn't go in the order of the smaller number
It doesn't go in the order of the smaller number.
for the...
4-butane would go before ethyl. Yeah. Okay. So, have you guys looked at the second page? Which one do you want to talk about? Good, let's talk about that third one. I like that. That's a good idea. Okay? Now, I've shown you guys the answer key for this, right? I'm going to load up the answer key so that you have it, or I'm going to hang it up so you can double check things. Okay? We're doing the third one right now. Thanks. If we take a look, this third one, if we do this chain, and be careful here, this is CH3CH, so that's actually 1, 2, 3, 4, 5, 6, 7 across. If we do this, we get 1, 2, 3, 4, 5, 6, 7, 8. If we do this one, 1, 2, 3, 4, 5, 6, 7, 8. Do we have, what else do we have?
We're gonna have to start at the top left and go all the way to
We're going to have to start at the top left. So if I count here, 1, 2, 3, 4, 5, 6, 7, 8. Is that where we got it? Like here?
Yeah, how do you get it?
1, 2, 3, 4, 5, 6, 7, 8. I'm counting carbons.
The carbon and run.
So if I do this one, right here, 1, 2, 3, 4, 5, 6, 7, 8.
But you're not touching that far left carbon.
This one?
Over and CH3 down. Right there you go. But it's part of this. That's part of the one.
Can I tell you something why I'm choosing this one over that one? They're both 8s. Do you agree with me there? They're both 8 counts. If I count this one, I got to figure out how to name this thing. And that would be like an isobutane or something like that. I don't want to name that. I'm being picky at which parent chain of 8 I want to name because of the fact that I don't want to name this big chunk here if I'm choosing this. If I choose this, I get a methane or a methyl, and I get a couple ethyls, and I get a propyl, right? If I choose this other chain, I end up with a branch CH, CH3, CH2, CH3. And I'd have to figure out what that name was, right? Do you guys agree with me? So I want to choose this as my parent group because then it keeps my substituents smaller. Because if I chose this other one to go down that way, I'd have a monster substituent right here. And that's not a big monster one. You probably can name it. It's a 4-carbon thing. It's a butane, right? It's a butyl, right? But it's not a perfect butyl. It doesn't start at the end of the carbon. At the end of the carbon, so then you probably have an isobutyl or something like that. And so I'm just avoiding that. That's all I'm doing. Okay? So I still have an 8-carbon chain. Which way am I going to count? I'm probably going to start here and count 1, 2, 3, because then I have a methyl group right away. Because if I count here, I get 1, 2, 3, 4 before I hit any substituents. So I'm going to count around here. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like I have a methyl group, or a methyl group at 3. I have 3 different ethyl groups, and I have a propyl group, right? So if I have that, we have to name the ethyl groups first. I have 1 ethyl at 4, and I have 2 ethyls at 5, right? So I'm going to write 4, 5, 5 dash, tri, right? Because there's 3 of them, triethyl. Then I'm going to dash ethyl, methyl, propyl. Which one comes next, methyl or propyl? LMNOP, methyl, right? So that's a 3 dash, it's a single methyl, right? And then finally, we have the propyl, right? Where's the propyl? On carbon 4, and it's by itself, right? 4 dash propyl dash, an 8-carbon one is octane. Kind of crazy, but kind of okay.
Why is there no dash between those two?
It's just a different way of writing it. They can write it both ways. They can put a dash there and they don't put a dash there. It's okay. Sometimes when it comes near the end, they try to avoid that. They write CH3s. They also, if you really want to get into carbon molecules, they start doing this, and the end of each one of these, you count a carbon. And they don't even write a CH2 or a CH3. They just draw it like this. So this would be a 1, 2, 3, 4, 5, 6 carbon molecule. So this would just be, what's 6? Hex. So this would just be a regular hexane molecule right here. Okay? Because they write them with those lines. And they don't add the H's, they don't even draw the C's. They like to draw it like this because these look nasty. This doesn't look so nasty, right? You know what this would look like that? It would be C bond, C bond, C bond, C bond, C, 1, 2, 3, 4, 5 bond, C, and then there'd be all these H's attached. Also, you guys know how lazy we are as scientists. No, I'm just kidding. Scientists aren't lazy. But it's much easier to draw a little zigzag. This equals that. It's the same thing, just a different drawing. That takes a long time to draw. This doesn't take so long. Good? Now, before I let you guys go to work on things. Now, this worksheet that you have is practice. I don't ever want it in. I'm not marking this one. Okay? So your answer key I'm going to hang up. Can I just hang it up just around the corner, attach it to a bulletin board somewhere so you can double check your answers? I want to talk about one more thing that your textbook talks about. Okay? So I want you to turn 700, what page is this? Sorry, 755. Okay, so there's these things called cycloalkanes. This is the last thing I want you to note. Now, a cycloalkane is basically a carbon molecule that is bonded in a circular form. So instead of just calling it a hexane, right down here, this is a 6 carbon, 1, 2, 3, 4, 5, 6 carbon molecule, right? If it's bonded in a circular form, you just put the word cyclo in front of it. Cyclo, 6 carbon, is cyclohexane. Okay? Now, if you move forward, the same thing kind of happens, though. It can have substituents. Okay? So you have to figure out how are we numbering them. Okay? And where do you start? Now, you number the ring starting with one of the substituents because there's no beginning or end in a circle, right? So you start with a substituent. So if I number here 1, 2, 3, 4, or if I number here 1, 2, 3, 4, I end up with substituents on this first one is 1, 3, 4, and I have substituents on this next one 1, 2, 4. What do you think would be the best part? Probably B. Why B? Because they're closer to the front, okay? And so we would call this 1, 2, 4 trimethyl cyclohexane. Notice here in your textbook there's no dashes in between the cyclo. I'm thinking there's no dashes because when I originally wrote them, there was no dashes in my answer key. And that's what I would remember back in the old day, okay? There's no spaces or anything then, right? So, it's pretty much the same thing except for you add the word cyclo and you start counting it as substituent, and the way you count is so that the substituents are lower. But it's the exact same thing with the word cyclo in front, okay? I'm leaving you with 20 minutes, right? Do you see this, page 758? I want you to do 13, 14, and 15. And let's just do ABCs. 13, 14, and 15, ABC. 14, you have to describe general properties. Just look up on the top of the page. There's chemical and physical properties of alkanes. You have a little bit of a reading too. Okay? So, page 758, 13, 14, and 15, ABC.